Okay, AP Calculus AB, Unit 4. This really should be Assignment 10. Unit 4 extra review. One last chance to get a little extra preparation. I'll show you the answers real quick. You can check them. Pause the video if you need to. Okay, so the answers to 10, 11, 12. 10, 11, 12. So, there you go. Okay, so let's see, slope of a secant line. That would be F3 minus F2, 3 minus 2. Plug 3 in here, it's 9 plus 6 is 15. 2 would be 8. 7 over 1. So the slope of the secant line is 7. Tangent line, you need the derivative. 2x plus 2. Plug a 2 in. And you get 6, the slope of the tangent line. Equation of the tangent line. Well, you need a point, which we don't have yet. Plug 2 in to original equation. Get 8. You already have the slope. We figured that out. Last problem. So it's going to be y minus 8 equals 6 times x minus 2. Just leave it in point slope form. Unless there's a really good reason. Number 2, we're going to do it the long way. So if you plug 0 in, you get 0 over 0 in determinant form. Probably a whole. We're going to factor out the whole. So we're going to do 3 over x minus 2 minus 3 over parentheses x minus h for the x minus 2. Make sure I put in parentheses over h. And the thing was h over 1. So I guess I'll simplify this a little bit. Okay. Now we need to combine these together into into a single fraction by giving the least common denominators. So that you're going to multiply this one by x minus h minus 2. So it's going to be 3x minus 3h minus 6. This is going to get multiplied by x minus h. So it's going to be minus 3x plus 6 all over h, x minus 2, x minus h minus 2. Now, our expectation is that there's a hole in the graph and that we're pretty sure it's at h, so we should be able to divide an h out of everything on top, so it cancels out. If terms don't have h, then that's not going to work. 3x minus 6 plus 6. That's what's left. Negative 3h. If that doesn't work out, something's wrong. So the h's cancel. That's the whole. We're going to plug h equals 0 in now. It's going to be negative 3 over x minus 2, x minus 2. That could be your answer. Or you could write a little more compactly if you want. There you go. So you're going to have a problem like that on your test. You're going to have some algebraic limits. Some of them I'm going to ask you to do L'Hopital's rule on. I would say 3. You should do L'Hopital's rule on. Probably just 3 on this worksheet. Plug 2 in, you get 0 minus 0. Now, I would think of this as negative x minus 2. It's the same thing. That's just going to work a little better, I think, with the top. So we would do a synthetic division. We're going to take a 2 out. 1, 0, 1, negative 10. 1, drop, add, multiply by 2, get 4, add, multiply by 2, add. You should get a 0. So this is now limit as x approaches 2 of x minus 2 times x squared plus 2x plus 5 over negative x minus 2. And there's the whole, cancels out. Plug 2 back in, you're going to get 4 plus 4 is 8 plus 5 is 13, divided by negative 13. Now, L'Hopital's rule, I would ask you to do a problem like this 2 ways on your test. So L'Hopital's rule is going to equal limit as x approaches 2 of the derivative of the top, 3x squared plus 1 over the derivative of the bottom is negative 1. Put 2 in here. 2 squared is 4 times 3 is 12 plus 1 is 13 divided by negative 1 is negative 13. Same answer. It's kind of nice. Okay. Number 4, this is in behavior. We're going to negative infinity get squared, made positive. Square root is still positive, so positive infinity over. If you plug negative in here, it's going to be positive infinity. You should get a positive answer. Now the dominant terms are here, 2x and negative x. You need to put absolute values around this. Okay. So if you just did 2 over negative 1, you would get negative answer. We know it's supposed to be positive. So this is going to force that to be positive, and this is going to come out positive. So it's going to be 2 over 1. And final answer is going to be 2. That okay. Number 5, right side limit. 9 plus 4 is 13. 9 minus 9 is 0. So it's going to be some kind of infinity, positive or negative. I would factor the x out of these. Okay, and then you're plugging in something in for x. This is just going to be 3, whatever, 0.001 or something like that. It's going to be negative. It's going to be negative infinity. Okay. Number 6, you should say, hey, that's a derivative. Let's do a shortcut on here. What's the function? X cubed. This is where the x's usually are. Function shows up twice, once with x plus h, once with x. Let's derive that just using the rule, power rule, 3x squared. And then because there's 4's in there, we're going to evaluate it at 4. So it's going to be 16 times 3 is 48. If you plug 0 in here, you get sine of 0 over sine of 0 is going to be 0 over 0. So there's a hole in the graph. We can't factor it, so we're going to use that pattern that we've seen multiple times. And so we're going to split this up into their own fractions. This would need 5x, this would need 2x. The x's balance each other out. This needs the extra 2 to balance out with that 2. This needs the extra 5 to balance out with that 5. That's 1, that's 1. Final answer is 5 halves. You could do L'Hopital's rule on that one too, but I'm not going to ask you to. Sketch graph under the following conditions. It's continuous and differentiable at A. Smooth, connected. It's continuous but not differential at B. So there's a corner or cusp or something at B. It's increasing concave down from 0 to B. Increasing and concave down. So maybe something like that. And it's decreasing and concave up to C. So it makes sense that there has to be some kind of, to go from concave down to concave up like that, and be decreasing, you got to get some kind of weird corner there. So something like that. Got a little motion problem. You're going to definitely have a problem like this. Multiple questions about one equation. So you've been given a motion equation. Find the position at 2. Well, that would just be plugging 2 into this. So 4 times 16 is negative 64 plus 256 plus 6 equals, let's see, this would be 262. So 198. Okay, average velocity. So V average, it's the slope of the secant line on a position graph. Velocity is the slope of position versus time, with the average evolving between 1 and 3. So you can do slope of the position curve from 1 to 3. And that'll do it. So probably got to figure out what S4 is. It's going to be negative 16 times 4 squared plus 128 times 4 plus 6. So 16 times 16 is going to be negative 256 plus, that's going to be 256 plus another 256, 512. So this will be 256 plus 6 is 262. No, something's wrong. 16 times 16 is 256, right? 36, carry the 3, 0, 6, 1, 6, 5, 256. That's going to be 256, 512, 512 plus 6 is 518 minus 256 is going to be 262, 262. Okay, 262. That makes sense. Okay. You know what? I made a mistake here. It's supposed to be going to 3. 3. Maybe we'll use that other one at some point. Okay, 3. Negative 16 times 3 squared plus 128 times 3 plus 6 is going to be 9. 90 plus 54, 144, 300, 60, 84 plus 6 is 390 minus 144, 6, 4, 2, 246 is going to be S3. So 246 minus, if you plug 1 in, that's going to be negative 10. That's going to be 118. And 246 minus 118 is 128 over 2 equals 64 for average velocity. Instant velocity is the velocity. So you got to find the velocity curve by the velocity function by taking derivative position, which is negative 32t plus 128. And then we plug 3 into it. There we go, 32. Position particle and velocity equals 0. We got to take our velocity. So when, so the first thing is you got to figure out the time. So when does velocity equal 0? Well, let's solve it. Time 4. So we need position at time 4. Now, luckily, I already did the work up above. It's 262. Times when for which position and velocity are both negative. So we should do line checks with these. I think we already have a lot of good information here. So position, well, we need to figure out when position equals 0. I don't think we've done that yet. So position equals 0. We factor out a negative 2. I think that's it. So I think we're going to have to do a quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So what's that going to be? 64 divided times 64. 16, carry the 1, 24 is 25, 0. 24, carry the 2 to 36 is 38. 6, 9, 40, 96. And that's going to be 32. That's going to be 96. So we're going to add another 96. 12 greater than 1, 18 is 19. So this is going to be 64 plus or minus square 4192 over 16. 2 times 2096. 2 times 1048. 2 times 524. 2 times 262. 2 times 131. Pair of twos. Pair of twos. 64 plus or minus 4 square root 262. It divided 4, everything in the top and bottom. 16 plus or minus square root 262 over 4. Square root 262, 250. Let's see. 12 squared is 144, 13 is 169, 14 is 2. I think 14 is 14 squared. 16, carry the 1. 0, 4, 1. Okay, 14 is 196. 15 is 225. 16 is 256. So this is a little more than 16. So one of the answers is going to be negative. And one is going to be positive. So we're not going to do negative time. Do we ever figure out when velocity equals 0? Yeah, we'll figure that out. It was time 4. So I'm going to do velocity line check time 4. And then position line check. This is about 16, so that's about 32. It's about 8. The positive answer. The other one's negative, like 0-ish, small. So this would go over here. 16 plus square root of 262 over 4. Test t equals 0 into your position function, and you get a positive, a negative. Test t equals 0 into the velocity, a positive and negative. So when are they both negative? Over here, from, we write that as a interval notation, from 16 plus square root of 262 over 4 to infinity. All right, that's kind of gross, a little gross. All right, sketching graphs of derivatives. I would say, well, let's look for 0 slopes. That's gonna be a solid dot at 4 because that's a smooth transition. Open dot at 2 because there's like a corner right there. So you can go to vertical. It's gonna be vertical asymptote. This is a constant slope of 1. So open dot, flat, constant slope. This is going to go to, these are all negative slopes. So this is going to negative infinity. So it's going to look something like that. Okay. Next one, 0 slope on the right, constant slope here. So constant slope from over there. And then it's going to be at 0, and then it goes to infinite positive slope. Over here it's going towards 0, so it's like a horizontal asymptote. These are all negative slopes. So it looks like this. This one, 0 slope, 0 slope, 0 slope. So, and this is nice smooth graph, so these are all going to be nice solid dots. Okay, these are all positive slopes. Negative, negative, positive, positive, negative, negative. So there's probably like a most negative slope there, maybe like -2 or something. So maybe something like that. And over here, they just keep getting more and more positive. And here's probably like the most positive slope. Maybe it's like that. And then it's still positive. It's getting smaller and smaller and smaller until it's 0, and then it starts going negative. Now, looks like an upside down quartic, whose basic equation would be negative x to the fourth, whose derivative would be negative 4x cubed, upside down cubic. Totally makes sense. Okay, we're going to use these table values to estimate it. So we're going to say it's about, and we're going to get rid of the limit, and we're going to say, okay, we're going to plug 4 in minus f of 4 minus 0.1 over 0.1. Now, even if they don't give you h, it should be the distance between each of these points. Okay? So even if h isn't given to you, it's easy to find. Now, from this picture, that's going to be 10 minus, this would be f of 3.99, which is going to, or 3.9, which is going to be 8 over 0.1. It's going to be 2 over 0.1. It's going to be 20 over 1. If you want to multiply top and bottom by 10 to get rid of the decimals, the answer is going to be 20. So you'll have a problem or two like that on your test. Those should be super fast if you know what you're doing. So that was some good extra practice. Be ready for your test.